Welcome back to a series of lectures on digital image processing. So in this lecture we are going to discuss about the accuracy of the classified images. Already we have discussed the different classification groups like supervised classification, how the system is doing by taking training of human intervention and classifying the object into different clusters or a group. And in second one we have seen how the system on its own it is classifying the images into unsupervised classification mode by making different groups or different clusters of pixel value into a unit called group, object or features. And then we found that no, there is still more problem with even individual pixel. Suppose what is the percentage of the occupancy of the individual element. So subpixel classification is one, classifying the variant of pixel itself. So we have seen three major groups of classification. Now our supervised classification output is ready for the further study. And once if you do classification by taking large number of pixels, now we will have to see whether the classification done by a system is correct or not. The question arises here, you are now going for checking the error, that is the accuracy. On what percentage of your classification is equal or is on par with the real future on the ground. It means what is the truth of your classification, what is the percentage of truth of your classification. So that is the understanding of the accuracy. Now we are now going to see how accuracy is being assessed after preparing the classification map. And the comparison of classification with ground truth data is called as accuracy assessment. This is the definition. To evaluate how well the classification represent, how well your classified images is mapping with real world data. And why do we bother accuracy? Because thematic maps we are preparing on land cover, forest type and other can be derived from classification by using satellite data in combination with other data sets. We need to tell map users how well it actually represents without what's out there. Without an accuracy assessment, this is not possible. A classified map is just a pretty picture. No, it's you cannot. If you are not justifying that what is the percentage of my accuracy, otherwise you cannot be able to use it. Assess how well a classifier work. What is accuracy assessment? Assess how well a classifier work. Interpret the usefulness of someone else classification. You will have to interpret also if somebody else did the classification. How we do the accuracy assessment? Collect reference data, that is ground truth data. You go to field, take spectroradiometer and collect the ground truth data, determining the class types at each pixels. Or suppose if you don't have spectroradiometer, maybe you collect the name of the object in the ground and bring back as a point information, and then I will tell you how it's being done. Compare the point information like the turbid water or a forest area or a land with scrub, something like that, some 10 pixels you collect randomly and then take it as the input value, give the input value to the supervised classified output, and then now you have overlay, or you can add a field to check whether my turbid water class and the turbid water class classified map is matching. If I am giving for 10 pixel, how many pixels is matching, how many pixel is not matching. How many pixel is matching is the accuracy, how many pixel is not matching is the inaccuracy. And similarly you do it for the whole area. Take a reference value and a map value. See the producer. It means how the system is giving the output. Check how many pixels are coinciding with this, how many is not coinciding. That is the producer value. And the output which is coming, that is the user value. That we will see with one table. Compare map with reference data. Interpret the result. Reference data possible. Make sure we can actually extract from the reference sources. There are many reference sources, like you can take it from aerial photo or ground truth to the GPS or GIS layers. Determine number and position of samples. Make sure to adequately sample the landscape. Variety of sampling scheme like random sampling, stratified random. This is what we need to know how to do sampling. Say for example, your area with two bigger, features, only two features. The first few features occupy nearly 70 to 80%, whereas the rest of the area which occupies the another feature. Now, how you are going for sampling? Now, if you are going for equal grid sampling, it is waste for 70-80%. You know that 80% area is only with only a single object. Then why you are going for equal interval? It means you are going for collecting 78 sample points, whereas you are going to collect 22 sample points for 20%. It is unmatching, unmeaningful. Why we want to waste our time? So now depends upon that sampling point will vary. Set your mindset to assess what is sampling, how to do sampling, and study a separate understanding capacity of sampling. You do random, stratified, systematic, and I am going to give you some examples of the sampling. The more reference plot, the better you get your results. In reality, you can never get enough, but normally you know that in the previous literatures, people giant in the field of image processing, Lillison and Kiefer suggested at least 50 per class. You take 50 sampling per class, but that depends upon the area. This is sampling method. This is simple random sampling. You have 1, 2, 3, 4, 5, 6 object. Now randomly you see there is no restriction wherever you feel, wherever the transport facility, wherever the object confusion you feel, maybe you go and collect observations or randomly placed and collected. This is stratified random. Stratified, you have the same object. Stratified random, it means this is one object, they have taken 5 samples, this second object 5, and you see this is bigger area, so they have taken one more sample. So similarly you see you can classify minimum number of observations or randomly placed. Minimum number of observations, no, that depends upon the area versus number of samples. It's random only. And this is systematic. You see they have made a very clear, so this is systematic sampling. Sometimes it is possible, sometimes it is not possible, because you will not get the connectivity of the area by road. You cannot even the travel. Sometimes unaccessible area will be the problem. Observations are placed at equal interval according to the strategy. Sometimes it will work, many times know that it is having problem. Systematic non-aligned, this is systematic non-aligned samples. Also classified, systematic random and systematic non-aligned. A grid provides even distribution randomly. You have a grid, it makes a grid, and then in this grid 2 samples, in this grid 2. You see in every grid only 2 samples are collected, and then the information is taken to ArcGIS platform for accuracy assessment. This is called a cluster. With respect to, you have 3 cluster. From 3 cluster, I am going to collect the samples. Randomly placed centroids. There are 3 centroids I have kept, and then I have asked my team members to get the observation systematically at all surroundings. This is called cluster sampling. And now after collecting the sample data from the field, and this data you please add a field in the ArcGIS and give the informations what you have taken by means of either spectroradiometer reflectance value, or even the label. Also you can match your label with the label which you have generated with the values already in the classified image. You just add it, and we are going to do practical also for understanding this. Now this will get little confusions, but it will not be a confusion, but once we do practical, we will understand that how that this point is connected with the classified image, how accuracy is assessed. But we will see the theoretical part of it. So randomly located sites, this information is compiled into the computer pixel by pixel. You can make a square array of numbers, rows and columns. The columns are normally represent reference data, and rows are represent the classified data. And you see there are this is the object. You have conifers, you have deciduous, you have grass, and you have taken this is the column value, reference data column. This is the reference data taken from the field, and this is the data. It is classified by the pixel. And you see here it's not 33, it is 13 only. Of course, by mistake it is over here. It is 13 only. So this is the data which is connected with conifer of conifer. Conifer reference I have taken, and conifer in the classified also 50 is matching. But total conifer classes, total conifer classes in the super classified image is 57. So out of 57, 5 falls in deciduous, 2 falls in grass. So out of 57, only 50 comes. The percentage of 57 of 50 is 88% is the user accuracy. But the conifer is also in the classified images were distributed as 14 in deciduous and 3 in grass. So this is 75 producer accuracy. This is how the accuracy is taken, and then cross diagonal total 71% is the accuracy assessment. Now of course what people are believing that above 80% is okay, it's okay, your accuracy is almost on par with the real ground system. But you can work, you can reclassify, do again the exercise, reclassify, automatically the error percentage will reduce. Now you see that how this is classified image. Classified image of the same value with respect to conifer, 14 in deciduous, 3 in grass. That's why total 67. In conifer, 67 pixels were classified as conifer. But 57 pixels only as per the reference it is coming. It means the 10% difference, 10 pixel difference distributed in the different classes. So that you have to pull and then group it into conifer, and then this is how the different accuracy is being classified. And you see you have deciduous, they have collected with 13 in number. But out of 13 they have collected 14 is matching, so 1 is mismatching with respect to deciduous. 1 is matching, and you see because of 1 13 or 14, so it is 27, 48% it is matching. Similarly, if you do cross check, and then you will be able to understand this. So producer accuracy, how well a certain area can be classified, this is called omission error. And user accuracy, it means probability a pixel class on the map represents a category on the ground, this is called commission error. So what does it mean? It has to be exactly matched, that is commission error. If it is not matched, what is omission error? Then you will have to bring the omission error into commission error. Overall accuracy and kappa hat, these are all the different methods that accuracy is being assessed, dividing the total number of correct pixels divided by the total number of pixels. Correct over total number of pixels is called overall accuracy. Kappa, measure the agreement between the classification map and reference data. Kappa coefficient is the method of assessing the accuracy. The kappa coefficient expresses the proportionate reduction in error generated by classification process compared with completely random classification. This is the formula used. Of course, kappa normally it will come by 0.463. It means it is better agreement than by chance alone. So normally this will be calculated by using this formula. And coming to the understanding of the present discussion is accuracy assessment to add value of remote sensing classification system. Ground truth data you are taking and then giving us an input for classification. Sampling design also play a major role for assessing the accuracy of the classified images. Accuracy assessment is an internal component of the information process. No, it's very, very important and internal component. This will make you confident and to say this many percentage of my classification output is correct. So with this understanding of accuracy assessment discussion has come to an end. Thank you very much.